So we've been talking about solving and graphing two-step inequalities. Two-step simply means that we have a constant that is being added or subtracted, and we have a number that is being multiplied by a variable. So the first thing that we have to do is identify a variable that we want to use. So the easiest way to do that is to look for what the question is asking us. So if I take a look at what is the greatest number of rides Daniel can go on, well, he's looking at rides, so let's let R equal the number of rides. That's the thing we're looking for. So that becomes our variable. When we write an inequality for this, start from the beginning. Daniel had $25 to spend at the fair. If the admission to the fair is $4 and the rides cost $1.50 each, okay, so we just identified each one of these rides is going to cost $1.50. So in order to find out how many rides or what it's going to cost for a given number of rides, we have to take those two things and multiply them. So we can start with that. If we take $1.50 times that R, and then we're adding to that a cost, the cost to get into the fair. It says it was $4, so we're adding that $4. And we're just checking to see, we're working on finding the number of rides that we can ride and still be less than that $25, okay? So it says, what is the greatest number of rides? I mean, he could spend exactly $25, possibly. So we put less than or equal to. And that's what makes it an inequality, because we don't want an exact amount, we want a range of amounts. So let's say he wants to ride only 5 rides. Can he do 5 rides? If he wants to ride 20 rides, is he able to do 20 rides? Okay, and that's what we want to find out. How many rides can Daniel go on? So when it says justify your answer, that means let's solve this inequality and work from there to say the number of rides that he can ride. So we rewrite the inequality. And solving this is just like solving a two-step equation. The only difference is we have an inequality symbol in between. First step we have to do, some people would draw that line down. I'm not a fan of the line with inequalities, but if you want that line, you just draw that line straight down, and that tells you the two sides of that inequality. Well, I hope we can see the two sides. Left-hand side, we want to get rid of the 4. When we do that to one side of an inequality or equation, we have to do that same thing to the other side. 4 minus 4 is 0, so that's gone. The only thing we have left on the left-hand side is 1.50 times R. 25 minus 4 is 21. And now, since we are multiplying 1.50 by R, we divide by 1.50. And if we take our calculator out, what we will find is that when we take 21 divided by 1.50, we get R is less than or equal to 14. So he could ride 10 rides, he could ride 13 rides, he could ride 14 rides and still be within that $25. Okay, and then it says to graph the solution on a number line. Well, we did a little bit of practice with this on our project where you had to draw a number line in. So we simply want a number line drawn. Again, I'm not overly concerned about how many numbers you put on that number line. You don't have to put every single tick mark all the way to 14. So if I did, let's say 5, and then 10, and 15, 14 is just below 15. Because it is a less than or equal to, now we want to put a closed circle at 14. And again, I'm estimating the location of 14. I can identify it by putting a 14 right underneath there so that everybody can see that that is my boundary. and then I simply draw that arrow. And you want to make it clear that your arrow is pointing to the left by putting the arrowhead on the end. And I don't think anybody will look at this number line and say, well, I'm not sure where the solution is. Now, it points to the left. We can't have a negative number of rides. That doesn't make any sense. We could ride 0 rides, but we can't go really any further below 0 because negatives don't make sense. But it is pointing in that direction. Okay, and that's number 1. Number 2, we want to do the same idea. 7th grade class is putting on a variety show to raise money. It costs $700 to rent the banquet hall that they are going to use. If they charge $15 for each ticket, this is the key to finding out what our variable is as well. How many tickets do they need to sell in order to raise at least $1,000? Okay, so how many tickets? It even says right there, right? That means that T is going to be my variable. So we're going to let T equal number of tickets. Okay. Notice that it says also we have a $700 fee to rent the place. So that is a cost. That's something that we have to pay for. We want at least, right here it says we want at least $1,000 raised. Okay, so I just did that backwards. Let me try that again. I would like to raise $1,000 or more. So everything on the left-hand side is going to be bigger than or exactly equal to the $1,000. So what do I have? I have a variable, T. The 15 goes with the T. So that means I'm multiplying 15 times T. And then I'm adding that $700 that we have to spend. Okay? On the left-hand side, we're getting our total amount spent. And we want to find out how many tickets in order to break even or better. We want, when I say break even, I mean we want $1,000. Okay, so now we solve that inequality. 15T plus 700 greater than or equal to 1,000. And I take away 700 from both sides. So on ticket sales alone, I need to make at least $300. So now I'm comparing just the 15 times T to 300. So I divide by 15, and I get T is greater than or equal to 20. Okay, so we have to sell at least 20 tickets. We can sell 20 or 100 or 500. Really doesn't matter once we go over that 20. So I draw my straight line, my number line, I should say, 0. Count by fives again, 5, 10, 15, 20. And don't be too worried about whether they're exactly the same distance apart. As long as you're numbering them, we get the idea that you mean that each one of these tick marks is 5. And then at 20 again, we put a closed circle. Make your circles big enough that you can recognize them. And then we have our arrow pointing to the right this time. Again, darken it in enough that you can see it as compared to the number line itself. And you're done. Now we can go on to page 2. I want to get you started with those, and I would like you to try them on your own after that. So if we take a look at number 3, we've got Kevin has $25. So when they tell you something like this, Kevin has $25, that means that's his total. That's the biggest amount that he's going to be able to spend. MP3 downloads cost 75 cents each. And I don't know if this is a real thing anymore, but if it says 75 cents each, that means one is 75 cents, two is $1.50, three is $2.25, and so on. How many songs can he download? There's your question. Songs, S, right? So let S equal the number of songs. And still have $13 left to spend. Okay? So we want that to be spent on something else. So that is the constant that we're going to add to that, to our left-hand side. Well, I know that the variable S is going to be multiplied by 0.75, and that's because of that word each. So I take 0.75 times S, and I add the 13. And I want to say that's going to be less than or equal to 25. That's the total that he had. Okay? Now, I would like you to solve that. You can go back to the other page, the other part of the video, if you need to. Just rewind it and see what I did first and second in order to solve that. When you draw your number line, again, this total is 25. Look at the answer you have at the end, and then determine what your number line is going to be spaced by. You can probably space by 5s, maybe 2s, maybe even 1s when you get finished with that. Okay, so in other words, if I put a 0 here, I might make my first tick mark 1, I might make it worth 2, I might make it worth 5. It all depends on how quickly those numbers rise, like how big is your answer. Okay, so give that a try, and then I would like you to finish by doing problem number 4 on here. Start to finish. Again, you're identifying a variable, okay, and going from there to write the two-step inequality. Once you're finished with that, then you can work on the problems on the next page.